So here we have Carl weighing at 12 years old, 82 pounds. And so we're going to consider that to be times 0. A is the original amount, so that's times 0. Time t equals 0. And that's going to be the weight. A is the original amount, that's 82 pounds. And then B is the growth or decay factor. Since this problem models growth, R will be positive. Make sure to rewrite the rate R as a decimal. So it says that his weight increases at a rate of 16% each year. So what that means is that R is equal to 0.16. So that's what that means. And then the B, though, remember our model is y equals a times b to the x. Well, there's our a right there. And then the b is 1 plus r, which is 1 plus 0.16, which is equal to 1.16. So when we use all of this information, again, there's b, there's a, and we write the formula. We use the formula y equals a times b to the x. We get y equals 82 times b, which is 1.16, and we raise that to the x power. And then what we want to do here, it says, what will his weight be after 5 years? Well, his weight after 5 years would be y of 5, meaning that when x is 5, and I may have steered you in a wrong direction here. I said t equals 0. Well, let's let that be x so I don't confuse you. My apologies. So that's going to be an x. That's a bad x, sorry, but it's still an x. So when x is equal to 5, we get the equation y equals 82, multiply that by 1.16 to the 5th power. So I want to show you how to do that on your calculator. So if you don't have your calculator handy, then pause the video and get your calculator. And if you don't have a calculator at all, then just watch what I do. So we want to type that in as 82 times, and then put parentheses around the 1.16, and we raise that using the up caret. That's the little symbol above the division symbol. Up caret, and we're going to raise that to the 5th power. And when we raise that to the 5th power, we get 172.228, which is what we see here on our paper. And then that means his weight will be about 172 pounds in 5 years. So when he reaches the age of 17, is predicted to be at a weight of about 172 pounds. All right, let's see if we can go ahead and get this next one done in this same video, and then we'll be done, because then you'll have to just do those next 4 examples. So we've got a motorcycle being purchased for $9,000 today. That's going to be our A value, and so we put that right there. 9,000 will be worth 6% less each year. That means that R, being 0.06, sorry, less, 6% less. So R is negative 0.06, because you round, or you convert 6% to a decimal. That's 0.06, and less meaning negative. How much will the motorcycle be worth at the end of 5 years? So when x is equal to 5, that's what we want to find out. So B is the growth or decay factor. R will be negative. Make sure to rewrite the rate R as a decimal, and we just did that. So we wrote B equals 1 plus R. So B equals 1 plus, and R again is negative 0.06, which would make B, 1 minus 0.06 would be 0.94. And then we write the exponential function. We use the formula y equals a times b to the x. We substitute in our a value of 9,000, our b value of 0.94, and we raise that to the x power. And then we're going to substitute 5 for x, and we go ahead and do that. Y equals, now I shouldn't write that like that. I don't really like that. I like y of 5 equals, because we just said y equals that. We can't just let y equal something with a 5 there. And then we have 0.94 again to the 5th power. So y of 5 would be when there's a 5 there. Y of x would be when there's an x there. And when we use a calculator, go ahead and do that here. We're going to type in 9,000. And then also, you know, if you write times and then don't use parentheses, 0.94, if you have a newer calculator, it'll still work, to the 5th power, we get 6605.136. So let's write that down. 6605.136. Y of 5 is approximately equal to 6605.136. The motorcycle will be worth about, that's a dollar amount, $6,605 after 5 years. And that, ladies and gentlemen, is how you do those kinds of problems. These are called exponential growth and decay problems. And these 4 problems here, I'd like you to go ahead and do these and bring them in on Monday so that we can look at them and check out the answers. And if I get enough time over the weekend, I'm going to go ahead and post the answers to these 4 problems so you can check to see if you got them right. Have a great night. I'll see you later.